Alright, so in your notes, draw a squiggly line. We're going to solve this two different ways. You pick which way you want to solve it any way you want on one of the two sides. This is the velocity of a particle moving along an axis. We're trying to find its position when time is 1 and when time is 5. See if you can do that.
-2. So it's plus
So that
16
is
over
t plus 1 to the -1.
16.
No, it's only 8.
We have to add 1, right? And so plus 8.
Yeah.
Well, if we're not sure, find the derivative of that. So that's negative
Oh,
8.
yeah.
T plus 1 to the -2.
I was finding the derivative. So we did do it.
Alright, so keep going. So that's what you were hung up on.
Yeah. What's after that? Then you put in the t. Yeah.
We'll go meters, I guess. What is that one?
125 over 3.
Over 3?
Oh wait, no, it's sorry that I thought you meant like the first part. It's just 44. The whole thing is
Exactly
just
44?
Yeah.
Did we get this?
Yes.
Everybody understands?
Yeah.
Okay, so literally everybody did it the same way. You just found C, you did an indefinite integral, right? Meaning we didn't go from wherever to wherever. So we had a plus C. What if I integrated v of t from 0 to 1? Well, I already know my antiderivative is 1/3 t cubed plus 8 over t plus 1. From 0 to 1, I will get 1/3 plus 4, which is 4 and 1/3, minus 8. So 4, 12, 13 thirds minus 24 thirds gives me negative 11 thirds. What did I just do? What does the definite integral from 0 to 1 tell us?
The area under a curve, which would just be position, because it's the antiderivative.
So why didn't we get 16 thirds then?
You guys started at 0, you started at 9.
Good. So how would I get 16 thirds given this negative 11 thirds?
9 minus 11.
Good. 9 minus 11 thirds, which is 27 thirds, which is 16 thirds. So the second way of doing the same problem with the definite integral, the 0 to 1, what does that tell us? The displacement of what?
Of 0 over 1.
The first one's like from 0 seconds to 1 second, it changed 11 thirds backwards. So if my particle started at 9, for 1 second I went backwards 11 thirds. Where am I at F1? I'm right here at 16 thirds. Okay, so then if I integrated from 0 to 5, we would get, let's see, 125 thirds plus 8/64 thirds minus 8. So 129 thirds minus 24 thirds gives me 105 thirds. That's 35.
9 plus.
Does that make sense? Because we started at 9 and we are now at 44. Okay, so two ways of doing the same problem. If it were me, I would do the way you did. Okay, but you have to understand AP exam questions will ask you, what does this give you? And you need to know what that is. Okay? It's the change in position from 0 to 1. Okay? This is the change in position from time equals 0 to time equals 5. So what if I asked you, what is the total distance the first 5 seconds?
You just add 9.
Is that a different question? Total distance?
Oh, yeah. Because you'd have to use what's below a curve, you would make positive.
Exactly. All area was positive then. So let's see if we can, if I asked you this, and this was a calculator part of the exam, see if you can do that. Using your calculator, find the total distance the first 5 seconds. Do we know how to do that? What's the easiest way?
Don't you just do absolute value?
Yeah, absolute value. So literally integrate absolute value of that stuff, and then you don't have to know whether how many times it crosses the x-axis, and just go from 0 to 5. See what you get. 40 miles per hour for 6 hours. How far have you traveled?
Is the rest of that one blonde?
40 times 6.
240.
I'm going 60 miles.
This is not a trick question.
240 miles.
So we get 240 miles, right?
Yes.
We can handle that? Yeah. This is not on the AP exam, sorry.
No.
It's on the ACT work keys, so
Oh, it is.
so it's
Oh,
literally
Yeah.
if you go to a concession stand and buy $3.25 worth of like food and you pay with a $10 bill, what's your change? Like, not kidding you. I'm not joking.
I'm ready for it.
Alright, so if I go 40 miles per hour for
30 seconds.
8 seconds, how
You'd be
far
going
have I traveled?
a fraction of a mile.
You might
You
want
go-
to convert.
320 mile per hour seconds,
Well, I mean, you're right, technically.
right? We never use this as a unit of distance, but technically, if you're in a bizarre world, you could use that as a distance. We know that it is distance because you have a rate times a time, just like I have miles per hour times hours. Those will cross off and get you miles. Nothing crosses off. Okay, so the only reason I'm telling you is I think there's 1 or 2 problems in your assignment where you're certain you did everything right, but they had their work in mile per hour seconds. So just be aware of that. It's not a huge thing.
What is this book?
I don't know why you would ever have anything. So it'd make more sense to change the 8 seconds to hours and then you have the miles, right? Right. Alright, only other thing, force is equal to kx, or x is a distance. So let's say I had took 10 pounds of force to go 2 feet. Well, then 10 would equal k times 2, so k would be 5, right? We can handle this again. So put 10 in for force, 2 for feet. So my k would be 5. So then my force equation in this problem would be 5x, because I replaced my 5 with k. Okay, so now work is the integral of force. So if we wanted to find the work there, you would integrate 5x and evaluate. Let's say I wanted to find the force to go from 0 feet to 2 feet. Did they say force? Sorry. If I want to find the work to go from 0 to 2 feet, I would integrate from 0 to 2 my force equation, and that would get your answer. Okay? It's called Hooke's law. Pretty straightforward. The only problem would be you forgetting force and work. Just memorize what that is. That's toward the end of your assignment. Questions on anything?
So force is in pounds and not newtons?
It depends if it's metric or in standard. Yeah.
Okay. It's not so hard.
Yeah. typically, you probably have more experience with newtons and meters, right?
Yeah.
So 1 through 8, you're given the velocity in meters per second of a particle moving along the x-axis. Use analytic methods to do each of the following. A, determine when the particle is moving to the right, to the left. Stopped. Find the particle's displacement for the given time interval. And the total distance. All right, so if a particle is moving to the right, what do I know?
It's above the x-axis.
What's positive?
Total value.
The velocity. No, velocity can be.
So is that true? If the velocity is positive, it's moving to the right?
Yes.
Oh.
So that, we're given our velocity equation. We want to know when it's positive. So this is above the x-axis, or in this case the t-axis. Our particle is moving to the right. Below the x-axis, it's moving to the left. And right on the x-axis, it's stopped. Okay, so let's see if we can make a sketch of this. So that's what you do with all these problems. You want to know when it's above the x-axis, below, and that will give you the answers to those. But I picked this one just because it's a fun little sketch without a calculator. So let's start by finding our points where it is on the t-axis. So set those equal to 0 and solve. So t is equal to 0 square root, so it's basically sine t equals 0. So that's, where is sine 0? And 2 pi. All right. Good guess. Cosine is 0 at. All right. So on our axis. That's a t-axis. We know that, and it's 0. So we're gonna it'll intersect the t at all those points. All right. So you remember back in polynomials, if you have something squared, what happens? It's a double root. Graphically, what does a double root tell you? It's an algebra 2 question. If you have a double root,
Parabola.
like if you have y equals x squared times x plus 3, what's going to happen at 0 here? It's okay if we don't remember.
It's gonna be 0.
It's going to bounce off. Remember, a double root bounces off?
What does that mean?
Yeah. What's a double root?
Multiplicity 2. It's a double root, meaning it's something being squared. If it was cubed, it'd be a triple root. Do you remember triple roots?
No.
Not if you don't remember double roots. So if I had y equals x cubed, that is a triple root. What happens at 0, 0? It does the little what up as it goes through. That's a triple root. It's called an inflection point. We now know what an inflection point is at 0, 0. So the double root's going to bounce off. A single root's going to go through the axis. Triple root's going to do an inflection either like that or like that as it goes through. Okay, so I have, when sine is being squared, those are double roots at 0, pi, and 2 pi. So it's either going to bounce off from above or below at 0, pi, and 2 pi. So let's start by at least figuring out whether it starts above or below the x-axis. So let's plug in pi over 4 to see if we're above or below. So that's going to be a positive number squared, positive. positive, does everybody see that if I plug in pi over 4, I'm going to have a positive answer?
Yeah.
Let's not do the work to figure out just positive. So we're bouncing off at 0. Then at pi over 2, it goes through. It's going to bounce off at pi, go through at 3 pi over 2, and then bounce off at 2 pi. Hey, there's a sketch. You could verify if you wanted to type it into your calculator, but that's kind of what it would look like. So, where does the particle move to the right?
Between 0 and pi over 2, and then 2 pi over 2.
Good. So, from 0 to pi over 2 and 3 pi over 2 to pi. Left would be right here, correct? It stopped at all those. It equals 0, pi over 2, pi, 3 pi over 2, 2 pi. What's the displacement? So this is the displacement between 0 and 2 pi.
Total area? Oh no, that's total distance.
Yeah, it looks like it's pretty close to 0, right?
Yeah.
Like, there's some positive, there's some negative, some more negative, oh, just as much positive. Okay, so how could we do it analytically? What are we finding?
The integral.
The integral from 0 to 2 pi of our function, right? Is that our answer?
Yes.
That's our displacement from 0 to 5. That takes into account positive and negatives.
You just give like an integral, you don't have to solve it out.
That looks like. How would I solve that integral?
Calculator.
I think the direction says to
Yeah, you
use
can
analytic methods.
U substitution.
U substitution. What would your U be?
Sine squared.
Sine t. That's what I would do. Because the derivative of sine is cosine. That'll get rid of that. It'll just be a U squared. Okay, you can do that after I'm done talking, which is very soon. And find the total distance. So you could do an absolute value, but we're supposed to do it analytically. So
That is analytically.
you're supposed to integrate from 0 to pi over 2,
And
and then from pi over 2 to pi, but that'll be minus, right? Minus a negative. So basically, find those four up and add them. I think that each of the areas are the same, just so you know. Alright, questions on this?
Wait, do we need to sketch all of them?
Yeah, those like 1 through 8, make little sketches. This is probably the toughest one.